Hello and welcome to part 2 of lesson 2.0. We are going to continue proving these theorems. Now we're going to look at the converse of the alternate exterior angles theorem. If two lines are cut by a transversal, then alternate interior angles are congruent. Take a moment and tell me what you think what you think the given statement and the proof statement could be. All right, now let's take a look at what I think it is. Well, the given is definitely K parallel to L, and I chose angle 2 congruent to angle 8 as my proof statement. You could have also done angle 1 congruent to angle 7. Now we need to choose a helper angle to help us get through this proof. Remember, we want it to be corresponding with one of our angles and have a nice, easy, either linear pair or vertical angle relationship with the other one. I'm going to choose angle 3. Because it corresponds with angle 8 and it's vertical to angle 2. I will say I think angle 6 would have also been a good choice in this case, but I'm going to use 3. All right, let's now fill in the beginning of our table. So once we have the beginning of our table set up, we're going to start off by looking at how our helper angle relates to the two other angles. I'm going to start off by looking at angle 2 and angle 3. We know that they're vertical angles, therefore we know that they're congruent. So we're able to say that by the vertical angle theorem. Now I'm going to look at how 3 and 8 relate. Well, we know that they're congruent by the converse of the corresponding angles postulate. And now we have the lovely situation. 2 is congruent to 3, and 3 is congruent to 8. So by the transitive property, I can say that angle 2 is congruent to angle 8 by the transitive property of congruence. So that was a nice, easy proof, only 4 lines. We like that one. Let's go on to the next one. Now we're going to look at the converse of the alternate exterior angles theorem. We start off with our if two parallel lines are cut by a transversal, then consecutive exterior angles are supplementary. So my given is going to have to be that the lines are parallel, and my proof statement is going to have to do with the fact that a pair of consecutive exterior angles are supplementary. I'm going to choose 2 and 7 for my exterior angles, and I'm going to... Now, as with all of these proofs, I want to find a helper angle that has a relationship to both of these. Ideally, it's going to be corresponding to one of my angles, and then I want it to be either a linear pair or vertical angles with the other one. I really like angle 4 because it corresponds to 7 and it's a linear pair with 2. I would have also been happy with angle 6 as my helper angle. So now let's start our proof. So we always start off with the given, K is parallel to L. And now we're going to talk about the relationships between our helper angle and the two other angles. I'm going to start by looking at 2 and 4. Well, we know that 2 and 4 are a linear pair by their definition, and we know that linear pairs are supplementary. So that's going to be my first. So we've done our statement where 2 and 4 are a linear pair, and therefore 2 is supplementary to 4 because that's the definition of a linear pair. Now, if things are supplementary, we also know that they add to 180. So that's going to... So pretty much, once we've written that down, that's all we can say about the relationship between 2 and 4. We can say they're a linear pair, therefore they're supplementary, therefore together they add to 180. Now let's look at the relationship between 4 and 7. Remember, that's my helper angle and the other angle I'm interested in. Well, they are corresponding angles, and our lines are parallel, so I can say that they're congruent to each other. And I'm able to say they're congruent to each other by the converse of the corresponding angles postulate. Now, because we're dealing with things adding together and we've got an equal sign floating up around higher in my problem, I'm going to need to convert that statement to a statement of equality using my definition of congruence. And now we've got a really great situation here. I've got 2 plus 4 equals 180, so there's 4. But I also know that 4 is equal to measure of angle 7. So I'm now able to make a really wonderful substitution step here in line 7. So now I can write that measure of angle 2 plus measure of angle 7 equals 180 by the substitution property of equality. And remember, we're trying to prove that 2 is supplementary to 7. Well, I'm right there. If two things add to 180, then we're able to say that angle 2 is supplementary to angle 7 by the definition of supplementary, because that is what it means to be supplementary. And at that point, we now have reproduced the exact proof statement, so we are done with that proof. Let's look at the next one. Our next proof is going to prove the consecutive interior angles theorem. Well, this is going to be an incredibly similar proof to the one to the consecutive exterior angles theorem, but let's take a look. It says, if two lines in a transversal form supplementary consecutive interior angles, so that's going to be part of my given, then the two lines are parallel. So I know my proof statement is prove the lines to be parallel, and my given statement, I need to choose two consecutive supplementary angles. So I'm going to choose 4 and 6. I could have also chosen 3 and 5, but I'm liking 4 and 6 today. So I'm going to say that angle 4 is supplementary to angle 6, because remember we're given that the consecutive interior angles are supplementary. So that's my given statement. And at this point, I'm also going to choose a helper angle. I'm liking angle 2 because it corresponds with angle 6 and it makes a linear pair with angle 4. I also would have liked angle 7. Anything else would make life a little bit too complicated. So those are the two angles I like, and let's take a look at the beginning of the proof. So we can start with that angle 4 is supplementary to angle 6 because that's what we were given. Now, I want to unpack what it means to be supplementary before I go any further. That means that those two angles add to 180. So I write that in my proof. Measure of angle 4 plus measure of angle 6 equals 180 by the definition of supplementary. At that point, that's kind of all I can say about those without taking into account something else. So now let's take a look at our helper angle. I want to look at angle 2 and angle 2's relationship with angle 4. Well, angle 2 and angle 4 are a linear pair, and linear pairs are supplementary, so those are my next two steps. I'm able to say both of those statements by the definition of linear pair. Well, 4 says that 2 is supplementary to 4. Again, I want to unpack that. What does it mean to be supplementary? Well, to be supplementary means that you add to 180 degrees, so that's what's going to happen. Well, something really cool is going to happen now. When I look at this, I've got a statement equal to 180. Then I have another statement equal to 180. Well, that means by the transitive property, I can set those two statements equal to each other because they both equal 180. Measure of angle 4 plus the measure of angle 6 must be equal to the measure of angle 2 plus the measure of angle 4 by the transitive property of equality. Well, now something really awesome happens. If you look here, you can see that we've got the measure of angle 4 on both sides. That means that if we use our subtraction property of equality, we can end up with measure of angle 6 is equal to the measure of angle 2. Again, by subtraction. And if those two angles are equal, then we also know that they are congruent, wrong symbol, angle 2, by the definition of congruence. And 6 and 2, when I look up at this figure here, 6 and 2 are my corresponding angles, and we have a theorem that says if corresponding angles are congruent, then the lines are parallel by the corresponding angles postulate. And boom, we finished the proof. Huzzah. Let's look at the next one. So this proof, we're going to prove the alternate exterior angles theorem. If two lines in a transversal form congruent alternate exterior angles, then the two lines are parallel. So my then statement, the proof statement, are the lines parallel. K parallel to L. And my proof statement, I need a pair of congruent alternate exterior angles. So I like 1 and 7 for my alternate exterior angles. You could also choose 2 and 8. Doesn't matter. So I'm given that angle 1 must be congruent to angle 7. Those are my congruent alternate exterior angles. And now I also want to choose a helper angle. Remember, your helper angle wants to correspond to one angle and either be vertical or a linear pair with the other one. I'm liking angle 5. But you could also choose angle 4. But I like 5 because it corresponds with 1 and it's vertical to 7. And if I talk about its relationship with both of those angles, I will eventually get the lines to be parallel. So let's begin, shall we? So we give our statement, reason, and given. Well, let's first talk about the relationship between angle 5 and angle 7, because that's something I can talk about immediately. I can't yet discuss the fact that 1 and 5 are corresponding angles, because unless if I know those lines are parallel, then I can't say that those angles are congruent. But what I can say right now is that these guys right here are congruent because they're vertical angles. So we're able to say that they're congruent by the vertical angles theorem, but now look, I've got 1 congruent to 7 and 5 congruent to 7, so now I'm able to say that angle 1 is congruent to angle 5 by my transitive property of congruence. And so if those are congruent angles, well, they're corresponding angles, therefore I'm able to say that my lines are parallel by the corresponding angles postulate. And at that point, I have proven that statement. Let's look at our last proof. If two lines in a transversal form supplementary consecutive exterior angles, then the two lines are parallel. So my conclusion, two lines are parallel, we like that, K parallel to L. Now let's talk about the beginning of it, supplementary consecutive exterior angles. So I want consecutive exterior angles. I'm liking 1 and 8, and I want to say that they're supplementary. Angle 1, supplementary to angle 8. And I want to choose a helper angle. Remember, my helper angle wants to correspond to one of my angles, and in this case be a linear pair to the other angle. I'm liking angle 3. Angle 5 would have also been a good choice. I like angle 3 because it's a linear pair with 1, and it corresponds with angle 8. And we choose the corresponding angle there because a way for us to prove lines to be parallel is to show that corresponding angles are congruent. So that's really the goal of this proof. So now let's set up the table. So we've written down the given, but my next step needs to unpack what that given really means. Well, supplementary means adds to 180, so that's my next step. And now I'm going to look at the relationship between angle 1 and the helper angle, angle 3. And I'm choosing those first because, again, until we've proven the lines parallel, I can't say anything about 3 and 8. Well, angle 1 and angle 3 are a linear pair, and we know that linear pairs are supplementary, and we know that supplementary angles add to 180. So that's what I'm going to do for my next 3 steps. So we've done that. We've said it's a linear pair. We've said they're supplementary, both of those by the definition of linear pair, and we actually write down what it means to be supplementary. They add to be 180. Well, now if you look, we've got 2 phrases right here, both of which are adding to 180. And when that happens, that means I can take those 2 phrases and set them equal to each other by the transitive property of equality. And the reason we like to do that is because now I've got the measure of angle 1 on both sides of my equation, which means I can subtract it off both sides, just leaving measure of angle 8 equal to measure of angle 3. And now we can say that we've got these 2 things that are equal to each other. Well, if they're equal, they're also congruent by the definition of congruent. And why is that important? Well, when I come up here and look, 3 and 8, those are my corresponding angles. And the only real way we have to prove that lines are parallel at this point in our journey is with the corresponding angle postulate that says if you can show that 2 corresponding angles are congruent, then you can show that the lines are parallel. Well, we were able to show that those angles are congruent, so now we can conclude that our lines are actually parallel by the corresponding angle postulate. And woo, we are done. Thank you guys for hanging in on a really, really long lesson. I promise the next one will be shorter. Anyway, see you all in class. Thank you very much.